To the next one, find the Fourier transform of rectangular pulse. Find the Fourier transform of rectangular pulse. Okay, now this is our given question. Now first we'll write what is a rectangular pulse and what will be the limits of it. Now if we just consider this as axis, this is our x-axis on as t and y-axis as f of t. Rectangular pulse we are considering over here as one of the rectangular pulse whose limits are from 0 to t. So our function will become as f of t is equal to the amplitude of this rectangular pulse. Let us take as 1. We can take anything as a or 1. I am taking it over here as 1. F of t is equal to 1. For what range it is 1? For the range of 0 to t. Okay, and it is 0 elsewhere. So let us first write the formula for the Fourier transform. If I want to find the Fourier transform of the function f of t, which is given as f of omega, which is equal to integration over the limits minus infinity to plus infinity, the function f of t e power minus j omega t into dt. This is our formula. Let us substitute the value of f of t in this above formula. So f of omega is equal to integral. Now the limits will change to what? The limits will change from 0 to t. It changes from 0 to t, and the function this f of t is how much? It is 1. So this is 1 into e power minus j omega t dt. Let us take the integration of this. This will fetch as e power minus j omega t by minus j omega over the limits what? Over the limit 0 to t. Okay, let us substitute the upper limit and lower limit. If I substitute the upper limit and lower limit, I'll be getting as e power minus j omega capital T minus e power 0 divided by minus j omega. Now let us simplify this. I am taking the term as 1 by j outside. Okay, but I have the minus sign, so what it will become? Okay, my minus sign is there. Okay, and over here what term I am having? E power j omega t. E power j omega t can be splitted as e power minus j omega t by 2 into e power minus j omega t by 2. I'm just splitting that e power minus j t in this form, minus 1. This is as it is. Now I can rearrange this minus j omega t, I can get it to the denominator, so this will be minus 1 by j omega as it is. This is e power minus j omega t by 2 divided by e power j omega t by 2. This particular value I have brought it down. This particular value I have brought it down over here, minus 1. Okay, now let us still simplify this. So this is what? Minus 1 by j omega outside. I am cross multiplying this, that is e power j omega t by 2 is there. This if I cross multiply, this term I'll be getting as it is as e power minus j omega t by 2 minus this term when I multiply with 1, I'll be getting as e power plus j omega t by 2. Okay, now next thing is, let us remove the term of minus or exchange the term of minus. Fine. So if I exchange the term of minus, I'll be getting as 1 by j omega. I'm taking minus term inside, so this will become minus and this will become plus. So I can just rearrange this as e power j omega t by 2 minus e power minus j omega t by 2 divided by e power j omega t by 2. Now this is in the form of what? This can be written in the form of sine theta. Now how we can write this in the form of sine theta? I can write my sine theta formula as e power j theta minus e power minus j theta by 2j. Over here I have e power j omega t minus e power minus j omega t by 2 divided by, I should have j's over here. I should have the term 2. So what I'll be doing, I'll be multiplying and dividing by 2. Okay, let me multiply and divide by 2. If I multiply and divide by 2, I'll be getting as my term is over here omega. I'm multiplied with the term 2 and I have the term e power j omega t by 2 that I'm taking it outside. My inside term is e power j omega t by 2 minus e power minus j omega t by 2 divided by 2j. I have multiplied 2 numerator and denominator, and here I had j no, that I have taken it inside. Right, now next is what? This is 2 by omega e power j omega t by 2. This is in the form of sine theta now, so I can write as sine of what term I'll be getting as? I'll be getting as omega t by 2. Okay, now in order to get in terms of sampling, what does sampling function says? If I use sampling function, the sampling function says that sine theta by theta will give you the sample function theta. Now this is sine omega t by 2. This term, that is omega t by 2, is acting as theta divided by theta. So how do I get the value of theta? I can, over here this is omega t by 2, over here I have omega and t. You can get it down over here, or else let us multiply and divide by omega by t. It will be easy. Multiply and dividing by omega t by 2. Instead of arranging, we can do this as well. So I'll be getting as 2 by omega. I can take this term in the numerator as well. So this is e power minus j omega t by 2 into sine omega t by 2. This is in the numerator, as well as omega t by 2. I am multiplying and dividing. This I have divided. Multiply is omega t by 2. Now which terms get cancelled? Let me check. This 2 will get cancelled, this 2 will get cancelled, and this 2 will get cancelled, this omega and omega. So what is my left of terms? My left of terms is e power minus j omega t by 2 divided by, let me once again check what is the terms that are being present behind, sine omega t by omega t into t. This is, I'm just once again writing for the convenience, sine omega t by 2 divided by omega t by 2 into t. So our f of omega is equal to t e power minus j omega t by 2. This is in the form of sine theta by theta, so this will change as sampling function of theta, that is omega t by 2. hence transform of rectangular pulse is being given by the function, this one. It's given by t e power minus j omega t by 2 sample function of omega t by 2. Okay, now when we are taking the rectangle pulse, we can also assume the value of in my question I have taken from 0 to t as rectangle pulse. You can take the value as 0 to t by 2 as well, or any other value.